So when I was putting these lecture slides together, for some reason this slide was missing from the spring 2020 video, so let me just put it back in. So in this class, we always use 32-bit x86, and this means the canary is going to be 32 bits or 4 bytes long. If you're using a 64-bit system, then the canary would be 64 bits long. And in practice, 1 byte of the canary is always going to be 00 or the null byte, and the reason for this is it lets us stop an extra class of buffer overflow attacks. So an example of an attack that this would stop is a bad call to string copy. So remember that string copy takes in a pointer to a string, and then dereferences that pointer, goes to wherever it's pointing in memory, and starts reading off bytes until it sees a null byte, because strings in C are always null terminated. Now the problem is, if the attacker controls this call, the attacker can pass a pointer to somewhere on the stack that's not a string, and now string copy will go to that location, think it's a string, and start reading off bytes until it sees a null byte, but because it's not a string, maybe the string copy will never see a null byte and it'll just start reading off forever. And this could be bad because now maybe string copy is leaking all sorts of values off the stack that should be secret or that the attacker should not know. So that's bad. And the canary would stop this because now if you call string copy with a pointer to some location on the stack, string copy would still think that's a string and start reading off values, and that could still be bad, but at least eventually string copy is going to reach a canary on the stack, and because the canary has a null byte in it, now string copy is going to stop there. So you haven't really stopped the entire attack, but you've made it it could have been a lot worse. So you've made it less bad because now string copy will only read up to a canary instead of all the way up the stack. Now the downside to this is now you've lost some entropy, right? So the canary used to be 32 bits. Now 8 of the bits have to be 0. So now you only have around 24 bits of randomness to work with. And depending on the situation, this might not be enough. And the attacker might be able to brute force the canary. So the attacker can just try every value until one of them is correct. And then their exploit works.